explained that voting is of two types. One voting is from stick, another is from ball. And when you get the voting at particular point, any point is receiving voting from each and every point. In the last
I have a question. In voting, the value of points change or not? For example, you said that O is a sender and P is a receiver. After voting, which value change? O or P?
Suppose we have to find out the result at point P. Okay. Now it will get voting from this point. It can get voting from this point. Say O dash. Now it's our imagination. Take them and imagine them on the same circle. This angle is theta, this is S. It will also receive voting from this point. And all the points which are surrounding point P, they will send their information.
Okay, and I think the direction of voting is important. If you start from one point to voting, the result is different from another point.
We have to add all the things, like we add electric field. Let me give a parallel example. Suppose there are some charges Q1, Q2, Q3, Q4, and we have to find out electric field here. What we'll do? We'll find electric field from here, here, and do the vector sum. Here we'll do the tensor sum, which will be summation or integration. So it will, how the electric field, how will you find the final electric field? When there are infinite points of charges all around it, you will just take the direction from different magnitude, and then you have to take the vector sum of all the electric field due to this one. The same thing is here. Tensor is coming from this point, from this point, from this point, from this point. You have to take not the vector sum, you have to take the tensor sum.
Is this the voting direction is unidirection or like two direction?
We have divided in 2D. We had divided all the things in two terms. E1, E2. For two dimensional, we have divided this one. The direction is called eigenvectors here. So everything, the tensor. Sorry.
Like O is you mean O is a sender, P is a receiver.
Yeah.
This direction is from O to P. I mean, can O be receiver? It will receive the vote from P. I mean, is this like a two direction thing, or it's like a unidirection thing?
No. The thing is that when we have to find out result at P, it will receive. When we have to find out at O, it will receive from P, from here.
Yeah, I know.
It depends. Right now we can discuss only one point who is receiver and the rest of them are sending.
Yeah, I know. But will we assume
it's two-way. The thing I think, what I understand, you are asking, yeah, it will be two-way because we have to find out the final tensor at point O also. Okay? Yes.
I have a question. If you have, for example, 10 points for voting, you must calculate the value of all of these points, and after that change the value.
Yes. That's why tensor voting is not a single stage.
And
tensor is building.
Yes, and if you have, for example, a lot of points, you must calculate all of the points.
Look, can we calculate, or can we take that voting from the point which is more than 45-degree angle? This is our starting. So we have a limitation that if this angle, suppose from here we are taking this point B. From tangent, if this angle is less than 45, it's okay. If point is here and my angle goes more than 45, we will not take the voting at that point.
For this point, but if you want to voting for all of the points, you must sum all of the points voting, and after that change the value.
I think the calculation he has done by integration from 0 to 2 pi. So he used in that manner. So we are not taking the discrete one, we are taking a continuous function and we are integrating it in the calculation. So by this 0 to 2 pi, it means you are covering all the points which are in a particular distance. Should I go ahead? Now, another basic thing, as I told you, basically in two-dimensional we have an ellipse, and ellipse can be converted into two things. Either it can be in a stick form or it can be in a ball form. So we have taken the board from a stick format. If it is this one, then how will cast the board to the neighboring points? The ball tensor is another type of tensor. Elementary type of tensor. There are two type of elementary type of tensor. One is stick, another is ball. It has no preference of orientation. As I told you, if it is ellipse, it has orientation in this direction. If it is ellipse like this, it has orientation in this direction. But if it is a ball, it means lambda 1 equals to lambda 2. Then it is this. It doesn't have any orientation. But it still can have cast meaningful information to another location. Even it is not oriented, it doesn't have any orientation, still it can send you important information. The reason is that, suppose this is a point. We are getting one disk here, one disk here. So it can, and for this point, it can create some orientation like this, or it can polarize. As I showed you in that figure in the last thing, we were getting just the at initial level. If you look at the second picture, we are getting just the balls, okay? But when the tensor builds up with the voting, we started getting some orientation in picture D, okay? So even this one doesn't have any orientation, but still the voting of this ball can give you an important information. And the formula for this one, voting is this one. The derivation of ball voting is called BS. B stands for ball. Ball voting from point S to O. This is represented by this formula, where R theta is the matrix, S is the decay function, S is the previous formula, this one, voting due to a stick. So what actually for ball tensor they have done?